Hi everybody, we are going to talk about inverse functions. Basically we are going to be thinking about solving backwards and finding the values of theta. So you're going to want to have your unit circle today, especially when you see the terms exact values. That is your hint that you are going backwards and using your unit circle. So if we start with something with the sine of theta equaling 1/2, if you use your unit circle, remember sine is your y value, and sine is 1/2 right here at 30 degrees, but it is also 1/2 over here at 150 degrees. So our answer would be that theta could be pi over 6 or 5 pi over 6, which is the same as 30 degrees and 150 degrees. So we are working backwards, trying to find the solutions today. So on your own, really quick, find out what theta would be when sine is equal to negative 1/2. Again, using your unit circle, sine is our y value. When is y negative 1/2? Down here at 330 degrees and over here at 210 degrees. So theta has two answers, 330 degrees, 210 degrees, and it also in the direction says to give it in terms of radians, which is 11 pi over 6 and 7 pi over 6. Okay, so those are pretty easy ones for us. Let's take it a step further. When is tangent of theta equal to negative 1? Now, what do you know about tangent when it's negative? Tangent is negative in quadrants 2 and 4. So that's where you should be looking on your unit circle. Also remember tangent is y over x. And so, sorry, I got interrupted and just hit pause really quick. But, okay, we know that tangent is y over x. We know that tangent is negative in quadrants 2 and quadrants 4. And we want to know when tangent is equal to negative 1. Well, if you look on the unit circle, the only time that we have y divided by x that's going to give us a negative 1 is when x and y are exactly the same. So right here at 135 degrees, and then the same thing happens down here at 315 degrees. So 135 degrees, 315 degrees, and in radians, that's 7 pi over 4 and 3 pi over 4. So we're just thinking, how do we work this backwards, right? Using the unit circle. Well, what if we don't always have something that's on the unit circle? How do we find the answer to theta thinking backwards? Well, you should know this already, but if you don't, if I gave you the sine of theta equals 0.2218, what is the angle? Well, you should know this, right? What angle or what key on our calculator do we use when we are trying to find the missing angle? And that's when we use the inverse sine key. So on our calculator, we are going to type in inverse sine of 0.2218. Now, my calculator happens to be in degree mode, so my answer is 12.8 degrees. I can also change to radian mode. Notice I didn't take my degree off and hit enter, and that is my radian mode also. Now, we can also do a couple other things with this. We typically don't say radians in decimals. We usually use pi, okay? So we can leave it like this or use the decimals as the decimal point. Now, that only gave me one answer. Everything we've done up to this point has been giving me two answers. My calculator will only give me one solution. So I have to think about, this is almost 13 degrees. So where else is sine positive that I can find the other reference angle to? Sine is also positive in quadrant 2. And I need to find the angle also right here. So how would I find that? 180, take away 12.8, and we are left with 167.2 degrees. So you are responsible to find both angles. I'm not caring so much about the radians at this point. You could take 167.2 and convert it into degrees, into radians, and so on. But right now, I'm more concerned that you remember that there are two answers to this, even though your calculator only gives you one. Okay? So, let's try another one of these really quick. Let's find out when the tangent of theta equals 0.88. So again, I'm going to go back to degree mode on my calculator. Inverse. Okay, I got interrupted again. Anyways, let's make sure that our mode is in degree mode. I'm going to hit the inverse tangent button of 0.8888. And we are at 41.6 degrees. Now, remember, we need two solutions. So where do I find my other solution? Well, think about, when is tangent positive? Tangent is positive here at 41.6 degrees, and tangent is also positive down here in quadrant 3. So how do I find that particular angle? Well, we are going to take 180 degrees, and this angle right here is the same angle down here, 41.6. So when I add the two of them together, I have 221.6 degrees. Okay? So you try one on your own really quick. Can you tell me when the cotangent of theta equals negative 5.71? Now remember, cotangent is the same as 1 over tangent of theta. So in our calculator, we are going to enter it in as 1 over the inverse tangent of theta of negative 5.671 degrees. So 1 over the inverse tangent of negative 5.671 degrees. Okay, that doesn't seem right, does it? So let me make sure that, oh, you know what? I told you to do it the wrong direction. So it's 1 over tangent, but if we're going to put it in our calculator, we're going to do it this way. We can either reciprocate this side, or we can reciprocate this side. So we don't want to do it this way, we want to do it this way. Because that just wouldn't make sense, right? So I know I did something wrong. So let's try this again. The inverse tangent of 1 over negative 5.671. That makes a whole lot more sense, doesn't it? Negative 10 degrees, okay? So theta equals negative 10 degrees. However, we're not going to keep our answer as negative 10 degrees because it said in the directions it had to be between 0 and 360. So if theta is negative 10 degrees, what positive coterminal angle is that? All the way around, this is a positive 350 degrees. So that's one of our answers for theta. The second answer, it comes from using this angle of negative 10 degrees. Where else is tangent negative right here in quadrant 2. So if this is 10 degrees in here, this is 180. Take away 10, or 170 degrees. So you are coming up with that second angle. Now, if you want something just to kind of help you, like how is this actually working or how is it not working, think about coming up with your angles. If theta is in quadrant 1, theta prime is going to be the same. 30 degrees is the same as 30 degrees, right? Now, if you're looking for theta prime or your inverse angle in quadrant 2, so here's our reference angle right in here, okay? This is theta. You're going to use that in quadrant 2, and it's going to be the same distance from here to here, but you're going to have to take 180 minus theta to find out what that angle is. Now, if theta is over here and my reference angle is down here, from here to here, what am I actually doing? I'm going all the way around 180 plus this point. So we have 180 plus theta in quadrant 3. In quadrant 4, what am I actually doing? If this is my angle from here to here, I'm going all the way around, but subtracting theta. So if that helps some of you, it might help make a little bit more sense depending on where the angle